Well, the recording's now on. People are still trickling in. I think we'll give it another minute or two. It's just about to the top of the hour. Yeah, Kevin, I just heard some system noises. I think that must be coming from you, so I think it's good. Well, it's just past 1. Maybe we'll give it till 1:01. You can start it up then. Welcome, everybody. This is session A12. Why and how to use Open SSL, SSL communication, and certificates. This presentation is pre-recorded, so it's just going to be a playback of a PowerPoint that was recorded earlier. But Kevin Mayfield, you may see him if you have a list, is the presenter and will be here to answer questions after the pre-recorded session is played back. So I guess we might as well go ahead and start.
And Sunil should also be on at the end to answer questions when we get to that point. So thanks,
Okay.
John.
Yeah, we just put your questions in the chat, and they will be addressed at the end. Go for it.
Good evening. Now let's begin our journey into Open SSL now. Okay, what I'll be covering in this session would be some of the advantages of using Open SSL, then supported versions of the products and SSL libraries, general concepts about what is certificate, private keys, and etc. How to create new client key store using Open SSL, how to create new connection manager key store using Open SSL. Okay, so why to use Open SSL? Open SSL is open source library, publicly available with short release improvement cycles. In this case, what happens is user has a more control over release version of OpenSSL to use. Customer can get and install new OpenSSL release versions and benefit from them immediately without waiting for an IBM product release or special build. GSKit is IBM proprietary and as such, neither freely nor separately available. Instead, GSKit is packaged and if required installed with each product that needs it, like CSDK or IDS. Delivering security fixes requires a product release or a special build. Now let's look at which all the CSDK versions support, which SSL library, and etc. So client SDK 450XC4W1 onwards, support for OpenSSL connectivity is enabled. So CSDK 450XC4W1 uses OpenSSL libraries for encrypted communication and does not have IBM proprietary GSKit libraries. CSDK 450XC5 onwards, user has a choice which libraries to use for encryption, either GSKit or OpenSSL. CSDK 450XC3 and before does not have OpenSSL connectivity, and it uses only IBM proprietary GSKit libraries for encrypted communication. The OpenSSL version 1.0 is supported by Client SDK 450XC4 W1 onwards. So here I would like to clarify here that the CSDK 450XC3 and before were supporting and are supporting SSL communication, but they are supporting SSL communication using IBM proprietary GSKit libraries. Now let's look at what is certificate, what is private key, etc. So SSL or TLS uses asymmetric encryption to encrypt a symmetric encryption key. During the key exchange of the initial SSL handshake, the symmetric key is then used for the remainder of the session between client and server. Asymmetric encryption uses a pair of public and private encryption keys. Server certificate contains the server's public key and a signature. The public key matches server's private key. The signature is used by the client to authenticate the server. The credibility of a certificate is guaranteed with the signature of either the certificate owner himself, that is self-signed certificate, or a public certificate authority, which is trusted by both client and server. The certified certificate authorities could be VeriSign, etc. The CA certificate itself is authenticated by its CA certificate, which may either be self-signed, that is root's CA certificate, or an intermediate CA certificate is guaranteed by yet another certificate authority. Let's look at SSL and TLS key store and its handling. So SSL TLS key store for database client contains servers, self-signed certificate or CA certificates that signed the server's certificate for the authentication of the database server during the SSL handshake when connecting to the server. A key store for connection manager also contains connection manager's private key and connection manager's certificate. Key store access is always password protected. Database clients only read the key store, but need the password to access it. To avoid having to provide the password for each key store access, the password can be stashed. The administration of key stores is done with GSKit or OpenSSL tools. Let's look at some of the differences between OpenSSL and GSKit. GSKit supports standard PKCS12 format as well as the proprietary CMS format having .kdb extension, whereas OpenSSL supports standard PKCS12 format having .p12 extension. Password stashing. The secret password encryption algorithms used with GSKit and OpenSSL are different, and the names of the stash files or the password files are also different. In case of GSKit, it's .sth. In case of OpenSSL, it's .str. OpenSSL itself does not know about password stashing, but CSDK does. For use with OpenSSL, the password must be stashed anew using on-case stash utility, which is bundled with CSDK. Let's look at how we can create a key store for a client using OpenSSL. In order to do that, what we have to do is we have to first log in to the database server machine and extract the certificate from server's PKCS12 key store. Generally, server's key store is located in your informix.dir/SSL directory by the name of server, Informix server. So here's the command I will be using: OpenSSL PKCS12-in, then $informix server.p12 -pass-in pass:\server password -out ssl_keystore_label.cert.pem -ca certs -no keys. So what this particular command is going to do is it is going to go and look at Informix server.p12 file. Then it will provide its password. Then it will create a certificate file, or rather it will extract a certificate file from the key store, that is unencrypted one. And what it will extract into that file is all certificate authority certificates and no keys. What this no keys is going to do is it is not going to extract the private key from server certificates. So it's only going to extract those certificate authority certificates. If my server's CA certificate is self-signed, then I will be using the command below, where I'm just going to use it without my -ca certs option for it. If my server's key store is in proprietary format, that is proprietary CMS format or .kdb file, and it's self-signed certificate, then this is how I'm going to extract it. As it is created by GSKit, I cannot read it using OpenSSL utility. So I'll have to use the GSKit utility. The command is the utility command name is gsk8-icmd -cert -extract -db, then Informix server.kdb -pw password label name, which is my server's label name, and then -target, the name followed by name of a file where I want to extract it, and the format ASCII. if my server's CMS format keystore contains additional CA certificates, that means not just server self-signed certificate, but it contains the other certificates which are actually certifying my server certificate. Then what I'll have to do is I'll have to extract each and every certificate from server's key store by executing the command gsk8-capicmd with all the label names after hyphen label. So here I'm using SSL_keystore_label. This is assuming that my server's self-signed certificate name is SSL_keystore_label. But if my server certificate is CA signed, then I'll have to extract all those CA certificates. So each CA certificate label will appear here, and all those many files I'll be creating here. So if there are, let's say, chain of 3 to 4 different CA certificates, then I'll extract all those 3 to 4 different certificates in 3 to 4 different files. So keystore label files. Now the question comes here, how will I know that my server's certificate is signed by which all certificate authorities? Or in my server's keystore, which all certificate labels are available? So that list I can get using command gsk8-capicmd-cert-list-db informaticserver.kdb and as password. So this will give me a list of certificates available in server's key store. And then I'll extract each and every certificate one by one. And then once all those certificates are collected, then I will combine all of them using cat command and create a single ASCII file for all certificates. Now, next thing what I'll do is I'll transfer the output file, the SSL keystore label.cert.pem from my server machine to client machine. That file may contain a single self-signed certificate from server, or it may contain multiple CA certificates. Then create client key store using exported certificates in the PM file as input. So I'll do it by using command OpenSSL pkcs12-export-out client.p12. That's the name of my key store. Pass out, pass::client password, that's my client password, -in SSL_keystore_label.cert.pem -ca name label 1 -ca name label 2 -ca name label 3, etc. If I have multiple CA certificates, but if I have a single certificate, self-signed certificate from server, then only -ca name and server label name will come there. If you want to include additional CA certificates from another PM file into your key store, add the option -cert file and provide another certificate file name in the about command itself. Then once you have client key store is ready, you need to provide it, or you need to stash its password. So that I can do it using on case dash client.p12 and client password. So this will create .stl file along with this client.p12, which will be used to stash the password for your key store. Now let's look at connection manager and its key store. The connection manager has a unique role. It acts as a client as well as it acts as a server. So it acts as a client when it is connecting to IDS server, and it acts as a server when client actually connects to connection manager. Connection manager is part of CSDK, and in 450 XC4W1, a standalone connection manager uses OpenSSL. But if connection manager is installed in the same directory as Informix server, then it continues to use GSKit. So as it has a dual role to perform, its key store contains CA certificates needed to authenticate the database server. That is for connection manager's client role. Obtain such certificates and put them in the connection manager's key store as you would for a database client. Then it has its own certificate and corresponding private key. That is for connection manager's server role to authenticate itself towards the database client. Create these certificates as the database server and put them into connection manager's key store. If connection manager's certificate is self-signed, then get CM's self-signed certificate and put it into the database client's key store. If necessary, obtain additional CA certificates needed to authenticate connection manager and put them into the database client's key store. Let's look at how to create my key store for connection manager. So log into the database server machine and extract certificate from server's PKCS12 key store. Server's CA certificate is signed by a certificate authority. If that's the case, then we'll use OpenSSL PKCS12-in. Then your Informix server.p12-passin, then password-out, the certificate name .cert.pem, then CA certs, no keys. If your server's CA certificate is self-signed, then you will not use -CA certs option in the above command. If server's key store is proprietary CMS format and server's certificate is a self-signed certificate, then you can extract it using the gskit command, gsk8 -cmd -cert-extract -db from server.kdb password, give password label, use server's label target, name of the certificate file and format ASCII. If your CMS format keystore contains additional CA certificates that were used to sign the server certificate, in that case, if you do not already have such additional certificates in a separate PEM file, then you need to extract each of these CA certificates with a command like mentioned in previous slide, using appropriate label for each of them. So here's what you can do here is you can use GSK8 CAPI CMD -cert -list -db informix server.kdb -pw password. With this command, it will list you the list of all certificates available in server's keystore. Use those certificate names in the command here in this slide. Say GSK8 CAPI CMD -cert. Each certificate name will be coming here, -label followed by one certificate name, -target, the certificate name .cert.pem. Similarly, you can run this particular command multiple times as many certificates you have, and get all those certificates or get all those .pem files. After that, now you create a self-signed certificate for connection manager. So you will create a self-signed certificate for connection manager as OpenSSL REQ-X509-new key RSA 4096 key out cmkey.pem-out cmcert.pem -days 365-nodes. So it will ask you questions like country, state, locality, organization unit, common name, email address, all that information you can provide to this particular command. Then combine the certificates for server authentication, which you need, as well as connection manager certificate generated in previous step, into a single PM file, right, using CAT. So you have multiple CA certificates which were generated one by one by providing here the label name for each and every certificate. So all those PM files, along with the CM self-signed certificate which you have generated here, you will combine them into a single .pem file and use that pem file here in the next command. OpenSSL pkcs12 -export -out, then cmname.p12 -pass out, provide password -in key, cmkey.pem -in, certfile.pem -ca name, server label -name, CM label. So here, in this case, CM label is value provided in common name in the above command while creating CM certificate. So with this command, actual key store for connection manager is created. Now, as the key store is created for connection manager, now you will have to password protect it using uncase-dash. So then you can run uncase-dash, then your keystore file name .p12, and then connection manager password you can provide. So with this, we come to the end of the session.
So any questions out there? Just put them in the chat and we'll get them answered, we hope.
John, can you unmute Sunil as well? He's not.
Yeah, will do.
Sunil, do you see that question?
Yeah, I can see that. Okay, in new install, we recommend to start using OpenSSL instead of GSKit. There are some performance concerns about using one or other method. Well, as far as performance, we really don't think there are any performance difference there. It's just the matter of convenience. So if you feel that you're better off using OpenSSL, then you can use OpenSSL. There's no kind of performance benefit over GSKit or OpenSSL.
I would recommend using the OpenSSL format, the P12 format, so that you have compatibility with OpenSSL clients.
Right, that's correct. Instead of
That's
using
the biggest pain point, is the migration, is the incompatibility of the proprietary KDB format. At this time, the server is still being shipped with, configured with GSKit for its encryption. And the client is the only one that gives you the option for installation. The other point I guess I can add is that the OpenSSL on all of our platforms except for Windows is coming from the operating system itself. It was already installed in the host and not linked into the library. So it will use the version of OpenSSL you have installed. And you're free to upgrade that as long as it's a compatible version. Yeah, that's a good question. It has been considered a lot. The primary need for OpenSSL versus using GSKit in the server wasn't as important at the time. We wanted to have a lightweight mechanism for the client that didn't require the GSKit being installed or delivered with it. So it does seem like we'd be interested in making that change in the future. We just haven't committed to it yet. And because it would be it probably wouldn't happen in a fixed pack because of the potential impact, because we probably want to eliminate those, the risk of incompatibility, the things that we had to fight with the client, where you would end up, be completely committed on the server then too. So I think in the future it makes sense to move to an Open SSL, but we haven't investigated all of the side effects of that change.
Anybody else with questions?
I think Sunil, you did a good job, but nobody had any significant questions over the content, and I appreciate the presentation.
Last chance. The next session is 2 o'clock. Ask the experts so you can get more questions ready there. Here's one. Kevin, you see that?
Mm-hmm.
Okay.
I am not aware of the performance change versus GSKit. Was apparently, I mean, Thomas is saying that there is the first implementation of SSL. We need the first implementation of SSL that we released in XE4W1, or
I think we haven't had that kind of a performance testing done there, right?
no,
For
we
the
haven't compared OpenSSL versus
compared.
GSKit.
GSKit, right? We don't have that
No.
data.
I mean, the motivation for OpenSSL versus GSKit is really more of an environment driver. If it makes sense for you to be able to do that, if you want to use GSKit, you can do that. But ultimately, there's the rapid, fixing mechanisms that you would get with the native OpenSSL on the system. So there's an advantage to that update cycle. You can keep the OpenSSL patched and up to date, and not have to be worried about getting server updates to handle it, or GSKit updates. That said, there aren't as many, that's not the rapid security vulnerability issue for, as other, potential aspects of products might be. But it is nice to have that cycle available. Anyone else?
Last chance, or save them for Ask the Experts at 2 o'clock.
Hope to see all of you there.
I guess we'll wrap it up.
Thank you, John.
See everybody at 2 o'clock.
Thank you, Sunil. Thank you, John.
Thanks,
Thank you,
Kevin.
John. Thanks, Kevin.
See y'all in 20 minutes.
Bye, everyone.
Bye.
Bye-bye.
Bye-bye.